Hi, my name is Julia Hawkins. I'm an Irene audio preservation engineer at the Northeast Document Conservation Center. And over New Year, we posted a video about Irene, and it generated a lot of great questions. So we're going to answer some of those for you today. It is not, in fact, wizardry. It is science. This technology was invented by Dr. Carl Haber. Hi, Carl. He started to develop this technology as early as like 2009, 2010. And the lore of Irene is that Dr. Haber was listening to the radio and heard a piece lamenting about the degradation of lacquer discs. And he's a particle physicist. And he was like, I think that I could figure out some solution to this problem. And so, as one does, he got a MacArthur Genius Grant to support the development of this technology. And Irene stands for Image, Reconstruct, Erase Noise, etc., which is a backronym because the first recording ever captured by this technology was Goodnight Irene by the Weavers. So that's where it comes from. Irene is a non-contact optical scanning system. So these are actually cameras. If we can figure out how to spin something and take a picture of it, and it has grooves, we can digitize it, which is one of the benefits of the Irene technology. The system behind me is currently set up for disk scanning, but the interesting thing to know is that we can actually reconfigure all of this to accommodate different formats. So this whole system has like a completely different setup that I can create for cylinder scanning, for example. So it's pretty format agnostic, which is one of the benefits of the technology. The one that was in the previous video is our 2D camera, which is just a line scan camera. It takes super highly magnified pictures of a grooved carrier. And behind me is our 3D camera. So the 3D camera is actually a confocal microscope. So what it does is it shoots white light down into the grooves, and then based on the wavelengths that come back in focus, it makes a depth measurement, and it creates this whole topographical map of the object itself. And this is an example of a wax cylinder that was captured by the 3D camera. So it looks a little bit more like pulses, because wax cylinders are actually vertically modulated. Their modulation goes up and down. And all of this crap over here is mold, which is a really common problem for wax cylinders.
January 17th, 1941. Amherst College. The United States and the world.
Digitization is preservation, and in the audio department, we work with all kinds of different formats. We work with magnetic, we work with grooved media, and all of these formats have the problem that they are actively degrading. The original carriers that they were on, whether they are wax cylinders or magnetic tape, they're chemically deteriorating over time, and we need to migrate them into the digital domain in order to continue to preserve them into the future. So that's why we're making something digital out of analog. And for something that is very, very broken, which is typically what we are dealing with here in the Irene lab, using something that doesn't require a stylus is kind of the only option. This is not client material. This is a disc that I found. The thing about lacquer is that it is essentially this material that's poured over a substrate, which you can see is very shiny aluminum in this case. But the lacquer is very soft, and over time it loses the plasticizer in its chemical composition, and the lacquer starts to shrink. And as you might imagine, the aluminum doesn't shrink. So it tears itself apart, and there's not really anything that we can do about it. So at a certain point, something like Irene is kind of the only option for getting audio off of an object like this.
During the next hour and a half, NBC and its affiliated independent station.
Good question. The laser that was seen in the previous video is actually not what's capturing the data on any of these objects. The red line is called a microepsilon, and it's essentially a laser ranging device that helps to take measurements ahead of where the camera's actually looking, and it keeps the camera in focus. The light is actually what is capturing the data, and it does not harm the object. In this case, in the case of this camera, it's actually an LED, so it's super energy efficient and not hot at all. So you realize that's supposed to be played at 70 RPMs, right? I do, in fact. So what you were seeing in the original video that we posted was the spinning of the platter on the 2D machine. And because we're not directly playing back the object, we're creating an image. There's a couple of different factors that impact how fast that platter spins. One thing is the exposure of the camera, and another thing is the optical sample rate, which is mathematically related to the audio sample rate that we want. We want 96 kilohertz files, which are big, chunky, high-quality audio files. And so to get that on a 70 RPM disc, we need to take 80,000 samples a revolution, which is a lot of data, and part of the reason that the platter spins more slowly than just direct playback.
Well, now, a bookmobile, the bookmobile itself is really a truck, isn't it? It's a very large truck, kind of like an oversized bus.
Yes, it is. It's very large.
This is a very good question. So I'm going to get my handy-dandy picture again. So what the technology is actually doing to create the waveform is that it is using an edge detection algorithm to determine the point of contrast between the deep black of the groove wall and the bright white of the groove bottom. The 3D machine is doing something similar, but it's a little more complicated because it's 3D data, so we're not going to get into that. And then once it finds that point of contrast, it is laying data points via pixels along that line. As you will notice, there are some surface area issues. This is the actual surface of the disc. It has all of the scratches and the nicks and the crackle and the dust that is on the actual object. So if we're seeing this black here, Irene, when it actually creates the waveform, is also going to see that little nick. And so it's acting really like a digital stylus. It is resolving all of those little cracks as it resolves the actual audio as well. It's not a restoration tool, it is a preservation tool. So part of the appeal of using this is that you're kind of capturing the object in time by creating these images, which includes all of the damage that it has kind of suffered as an object just out in the world degrading. But the nice thing is, once you have the image, you've created something that you can use to make a very high quality audio file that you can then use to clean up later. So for our clients, we provide some courtesy access files that clean out a lot of the hiss, the crackles, the pops. There's also an aspect of optical cleaning that happens in the actual processing stage that gets rid of a lot of the super extreme outliers. So something like this, we're not going to have a crazy clip here because we'd be able to kind of limit it and eliminate that from the audio initially. But for the most part, we're creating something that is listenable, is clear. If a researcher picked up this file, they'd be able to understand the content. But we do not offer full restoration services. That is somebody else's department. So when we're talking about stereo and grooves, there are two sides to a groove. So let's imagine that's the outside of the groove, and then let's pretend that's just the middle of the groove. But as you can see, there are two sides, there are two channels. So in a stereo recording, this side of the groove has slightly different information and wiggles slightly differently than this side of the groove. So this is 1, 2. So in a stereo recording, these are different. Irene creates a line of data for one side of the groove and the other side of the groove. A lot of our historical recordings are not actually recorded in true stereo because it wasn't developed yet. But one thing about creating a 2-channel file is really useful because sometimes one side of the groove can be like weirdly worn in some way that the other side isn't. So when we capture both sides, it creates 2 different pools of data that we can use to get the cleanest recording possible. So regardless of whether it was originally recorded in stereo, we usually create 2-channel files because it's just more useful that way. That's all our questions. I hope this was helpful. I hope you guys enjoyed it. I think Irene's pretty cool. I feel really privileged to be able to work with this technology. If you'd like to email me directly, my email is jhawkins@nedcc.org. Or you can find me on our website. And yeah, I hope you guys have a great day. Thanks for hanging out.
Perhaps only because I've just heard about it, it seems so new to me. But how long have you been running it, and how long has the bookmobile service been operating?
The bookmobile was started in February 1950.